discuss the solutions.
Sir, no, it is not about the solutions.
Yes.
When I submitted the test before 20 means 119, but when I open the link, it's showing the questions. Means why it is like that? My response is submitted or not? I have doubt, sir.
If you have submitted, then the submitted. Don't worry.
Okay.
Okay, so can you see the questions?
Yes, sir.
Yes, sir. Sure.
So what inductive property of natural number says?
सर माझा रिस्पॉन्स सबमिट होत नाहीये.
आता वेळ संपल्यावर नाही होणार सबमिट.
काय?
वेळ संपल्यावर सबमिट नाही होणार.
मग
आता नाही होणार सबमिट. आता पुढची टेस्ट द्यायची. मी टाइम एक्सटेंड केला होता तरी सबमिट नाही केली.
सर
येस.
सर माझं क्विज लास्ट क्वेश्चनच्या आधीच ऑटोमॅटिकली सबमिट झालं.
ऑटोमॅटिकली कसं होईल? मग ते
म्हणजे
वेळ संपली असेल.
नाही, वेळ नव्हता. 1:12 झाले होते.
ठीक आहे, काय सबमिट झालं असेल, दाबलं गेलं असेल. ओके, डोंट वरी, विल कंडक्ट मेनी सच टेस्ट. सो विल टेक ॲव्हरेज ऑर मॅक्सिमम बेस्ट ऑफ 3-4 टेस्ट. सो डोंट वरी. Right?
Yes, sir.
So if there are any issues, don't worry, don't bother, don't get panic. We'll conduct many such tests. Either we may consider maximum or average. So you can try next time. Okay, so what is inductive property? If n is in natural numbers, then n plus 1 is also in natural numbers, right? Other three options are not possible. That you can see easily, right? If ABCD is a set, then which of the following is an equivalence relation? So first one is not equivalence. First one is not equivalence relation. Why?
Because it is not
Only
Not
reflexive.
reflexive.
it
Because
is not reflexive.
it is not related with D, so it's not reflexive. Second one is not what? Second one is not symmetric because A is related to B, but B is not related to A. Right. So third one is right. Third one is equivalence relation. Correct? Because all these two properties are satisfied.
Excuse me, sir.
Yes.
Sir, C comma B exists in this one and B comma A exists, but C comma A doesn't exist. So how can it be a equivalence relation?
Which C comma I?
Sir, in the last two, C comma B, like the last, the one you are saying it's correct. C comma B exists, B comma A exists, but C comma A doesn't exist. So it's not transitive.
So I am not saying where A comma C exists.
Sir, C comma B and B comma A.
So the set contain A comma C.
Sir,
So the
actually
last
none of
two
the
brackets,
options
if you
were.
consider them.
Sir, actually none of the relations were actually equivalents.
Yes,
sir.
sir.
Yes, sir.
Correct.
B comma C
Yes, sir.
comma okay. B comma C and C is related to B, B is related to A, and you are saying that A related to C.
C is not related to it.
Okay, okay, I will revise
Sir,
this
but
one.
last option is an equivalence relation.
Last
No.
one.
C is related to
No,
B.
A
B
is
is related to A, but there is no such option that C is related to A.
Right, so none of the option is correct. That means I will revise the solutions. Then you will get marks, no problem.
But sir, B is related to C is related to B, and B is related to B. There is an option. Third.
Which?
Yes,
Which
sir.
option?
Third is the right option.
Correct, sir. Third.
No. What he is saying ki C is related to B and B is related to A. Therefore, by transitivity, C related to A must be there. Right? Here transitivity fails. Is it clear?
Yes, sir.
Yes.
Right.
Yes, sir.
So I will revise the solutions. Then automatically it will get reflected in your marks. Anyway, let us go to the next
First one.
question. First,
Yes, sir.
so go to the next question. Define a relation tilde on R, x related to y if and only if absolute value of x is equal to absolute value of y. Then equivalence class of 5 is. So what are the elements related with 5? Right? That means if element is related with 5, then absolute value of if x is related with 5, then absolute value of x must be same as absolute value of 5, which is 5. Right? And therefore, which option is correct?
C.
Right? Fourth.
Fourth.
Right, because 5 and minus 5 are related because they have same absolute value, no other element. Correct?
Yes, sir.
Only two elements are in the class. Okay. If A is 1, 2, 3, 4, 5, then power set is power PA is a power set of A. Then how many elements are there in power set of A? How many elements are there in power set A?
32.
32, right? 2 raised to 5 because the cardinality of A is 5. Then in power set there are 2 raised to 5 elements by formula. Okay. If cardinality of A is n, cardinality of B is m, then how many elements are in A cross B, Cartesian product of A and B? Right? So product of cardinalities,
Yes,
m
sir.
into n.
M
Correct?
into N.
Right. So if A is empty set, then power set of A is empty set, power set of A is non-empty set, power set of A has two elements, none of the above. So which is the correct option?
Second. B.
Power set of A is non-empty set because power set of A contains one element which is the empty set. Correct?
Yes, sir.
But
Sir,
sir,
but the
empty
option
set
can
is
see
denoted by,
Yes.
but the empty set is
but
denoted
sir, the
by 5.
cardinality of the
Power
power
set
set can
is 5.
be 2 also, right?
No, what is power set of empty set? What is power set of empty set? A is equal to empty set. Then what is the power set of A? Empty set, right? Is there any other? What are the subsets? Power set of A is a set of all subsets of empty set. And what are the subsets of empty set?
Sir, it will be phi and set phi, right?
Of set phi.
Because it is above mentioned that A is phi, so it becomes a one of the set and the other can be set phi too, right?
No. If set A is suppose this, then what is the power set of A in this case? Empty set and set A itself.
Yes.
Right. So what is here empty set and what is set A itself in this case? Empty set and what is set A itself is empty set. So we cannot repeat same element again.
Yes.
Right?
Okay,
So
sir.
therefore
Understood
it
the
has
mistake.
only one element.
Okay, sir.
Right. So therefore power set of A is non-empty set. That is correct option. Power set of A has two elements. That is not true. Okay. Yes. Somebody wants to ask now. I cannot hear properly. I cannot hear properly. If you want to ask me clearly. Okay. Let us go to the next question. If A is equal to two element set A comma B, then which of the following is correct? Element A is subset of power set of A belongs to power set of AB belongs to power set of A, or set A belongs to power set of A. Right? Why the above option?
Correct.
Sir, there are two
One is
options.
also
One
correct.
is also
One is
correct.
also
Yes, sir.
correct.
First option.
Yes, sir. Answer C, sir.
No, why? What is set A? AB. What is a power set of A? Write down power set of A. Empty set A, B, and
And
AB.
then
AB.
Right. So can I say that this is a subset of power set of A? Is it true?
No, sir.
This is not true because this is a member. This is a member of power set of A. This is correct. There is a difference, logical difference. Right? So A is a member of power set of A. This is not true because there is no such member. Right? This set containing A is a member of power set of A. Right?
Sir,
Yes.
if in the first option there were two curly brackets, then it would have been a subset of power set of A, right?
No. Then it is subset.
Yeah. Okay.
If I take, is it true now? Is
Yes.
this
Yes, sir. Yes.
is
Yes,
this
sir.
because
Yes, sir.
if I have set A comma B, and when I say singleton element, then I can say that it is subset of A. But I cannot say that A is a subset of A. Right? Here it is not true. Okay, A is a subset. A is a member of A. A is not subset of A. But if I put A in some set, then it is subset of A. So the set singleton A is a member of power set of A, and if I put it in a set, then it is a subset of power set of A. Right? Yes. Therefore, the singleton's set A is a member of power set of A. Right. This is a member of power set of A. It is not a subset of power set of first option. So last option is correct. Okay, next. Suppose X is a three element set. Then which of the following is a partition of X? Right. So what is a partition of a set? Why second option is not correct?
Partition is a set of sets.
Partition is a collection of subsets which are disjoint and their union will give us. So this is a collection of elements of A only, not set of subsets. So we cannot say it is a partition. Right? But if I put this inside a bracket again, then this would be a partition. Why third one is not partition?
Because your intersection is not
Because
found.
second and third intersection is not empty.
So among two sets, intersection is non-empty. So this cannot be a partition. We want disjoint sections. Fourth one is also not a partition, right? Because the three members are not subsets, these are just elements. So only first one is a partition because 2 plus 1, two elements in one set and one element in second set, right? So let A is equal to 1 comma 2, two element set, then maximum number of equivalence relations can be defined on set A is. How many equivalence relation can be defined on two element set?
2.
2. Because how do we identify number of? So if set A has two elements, then how many partitions are there? Suppose A is two element set, right? So how many partitions we can have? 1 plus 1, right? 1 plus 1 is a partition, and what is another?
2.
2 at a time. There is no third partition possible, right? Is it clear?
Yes, sir.
Third partition is not possible. There are only two partitions, and how many equivalence relation? As many partitions. The theorem which we have already proved. Correct? So therefore there are only two equivalence relations we can define on set A. So define a relation R on set of real numbers as for xy belongs to R, x related to y if and only if sin x is equal to sin y. Then R is reflexive, symmetric but not transitive. Right? Isn't it not transitive?
It is transitive.
It is transitive. R is reflexive, transitive but not symmetric. So it is symmetric. If x is related to y, that means sin x is equal to sin y. Then sin y is equal to sin x. Right? And therefore y is related to x. Not reflexive, not symmetric, not transitive, which is not true. Equivalence class of 0. Equivalence class of 0. So what is equivalence class of 0? Right? So what is relation x related to y if and only if sin x is equal to sin y? Right? Sin x is equal to sin y. Now what is equivalence class of 0? All those elements, real numbers which are related with all those real numbers which are related with 0. Right? But what are the real numbers which are related with 0? When we say that number is related with 0, sin 0 is equal to sin x. That means those real numbers for which sin x is equal to 0. And what are the elements or real numbers for which sin is 0? Right? What are the real numbers for which sin is 0? Yes.
Pi, 3 pi.
Right. So 0, pi, minus pi, 2 pi, minus 2 pi, 3 pi. So n pi. Vary n over integers. You vary n is equal to 0, 0, n is equal to 1, 2, minus 1, minus 2, all such type of numbers, and therefore this is equivalence class of 0. Correct? Yes, is it true?
Yes, sir.
In fact, R is equivalence relation. So R is not equivalence relation is not true. Right. Okay, so test was not very difficult. Questions were very elementary. Only thing is you need to understand basic definitions, nothing else, right? Okay, any doubt? Do you have any doubt? Okay, no doubts. Okay, let us come to the point. What we were talking yesterday, define, does there exist a bisective function f from natural numbers to integers? Did you find solution, answer of this question? Do anybody knows the answer?
Sir, can I answer?
Yes.
Yes, sir. We can map 1 to 0 from natural numbers. We can map 1 to 0. Then every even number will represent a positive number. Like 2 will represent 1, 4 will represent 2, and so on. Or positive integers will be represented by even numbers. And then we were first saying that the first odd number will be mapped to the first, we mapped the natural numbers onto odd numbers, how that we said the first odd number would be 1, the second odd number would be mapped onto 2. We just shift that by 1, which means 3 will 3, that is the second odd number, will map itself to 1, 5 will be mapped to 2, then 7 will be mapped to 3, and so on.
Yeah, actually what we discussed yesterday. So according to yesterday's discussion, you are right. You can map odd numbers to
negative integers
and even numbers to positive, right? And so what is a function actually? So define f from n to z by. So what is the exact formula? Right?
Yes, sir. Can I? Okay.
Yes.
Yes, if n equals to 1.
Give me just direct formula. N by 2 if n is even.
N by 2 is n is even, and n plus 1 upon 2 if n is negative n plus.
But we want 0 also, right?
Yes, we can just map that to 1.
Suppose n is odd, then map it to minus of n minus 1 by 2. Right, so in this process what happens? Okay, let us go one by one. Where one will go? One is odd, right? One is odd, so where it will go by our definition?
-1. -1.
0. 0, right? See, one is odd, and where odd number is mapped? Minus of 1 minus 1 divided by 2. What is it? 0. Correct? Is it correct?
Yes.
Do you agree or not clear? Am I right?
Yes.
Yes? Yes or no? Where 2 will go? What is image of 2?
1.
Right, 2 by 2 because 2 is even, so it is 1. What is image of 3? 3 is odd now, but for odd, what is the formula? Minus of, what is it?
-1.
Minus 1. Where 4 will go? 4 is even, so 2.
2.
Where 5 will go? To -2. Now check this. So ultimately what is happening? All odd numbers are, so 1 goes to 0, 3 goes to -1, 5 goes to -2, then 7 goes to -3 and so on. And at the same time, even number goes to positive side. 2 goes to 2, 2 goes to 1, 4 goes to 2, then 6 goes to 3 and so on. And therefore in this way you can cover entire integers using only natural numbers. Do you see this? Is it clear?
Yes, sir.
Now prove that this f is bijection or bijective function. Now the function which I have defined, is it a bijective function? So first, is it 1 1? Is it 1 1?
Yes, sir.
Yes. So let n and m are two natural numbers, right? If their images are same, then if images are same, then what we expect?
Their images are
Three
also
images
same.
are also same. M is equal to n, that we expect. But then m and n are both even or both odd, right? If their images are same, then both are even or both are odd. It is not possible that one is even and another is odd. Why? If images of m and n are equal, then it is not possible that one of them is even and m is even and n is odd, or vice versa. Why? Do you understand what will happen if m is even and n is odd? Then what will happen? F of m is positive and f of n is non-positive by definition, because odd numbers goes to the 0 and negative side and even number map to positive side, and therefore if f of m is positive and f of n is less equal 0, this say that f of m is not equal to f of n. Correct? Which is not true, because we are assuming that images are equal. So if images are equal, either both m and n are even or m and n are both odd. Is it clear?
Yes, sir.
We understand if one of them is even and another is odd, then even number goes to positive side and odd number map to negative side, and therefore how their images can be equal, right? So not possible. So therefore both are even or both are odd. Suppose first case, suppose both are even. Case 1, if m and n are both even, then what is Fm is equal to Fn implies, what is Fm then if m is even? What is
M by
image?
2.
M by 2.
M by
And what is n by 2? But we can cancel 2, so m is equal to n. In this case, if images are equal, pre-images are certainly equal. What is the second case? if
M and N are both odd.
Both odd. Right, so if both odd, then Fm is equal to Fn implies minus of m minus 1 by 2 is equal to minus of n minus, because odd numbers are mapped to these numbers, negative numbers. And just simplify this minus minus, you can multiply by minus 1 on both sides, 2 get cancels. Right. 2 get cancels, what remains? M minus 1 is equal to n minus 1, add 1 on both sides, so m is equal to n. Thus, what is the conclusion? In any case, f of m is equal to fn implies m is equal to n, or m is not equal to n implies fm is not equal to fn, right? So if elements are distinct, then images are distinct, or if images are same, then preimages must be same. So this says that therefore f is 1 1. Right, so is it clear? Calculations clear?
Yes, sir.
Right, so f is onto function or surjective. So how to prove that f is onto? For any k belongs to integers, right? When we say that onto, when we say that f is onto, for every integer k, can we produce element in preimage in domain such that fn is equal to k? This we want. Alright, so choose any element from codomain. Right, what we want? Preimage for k. We want preimage for k. So how to produce preimage? What is a preimage for k? What is preimage?
Sir, if it is negative, it will be 1 minus 2n. And if it is positive, it will be just 2.
Right, if k is positive, then what are the preimages of positive number? Then n is equal to 2k. If k is negative, then what is it? Minus of what? You think about it.
Okay.
And what is the preimage if k is equal to 0? 1. Is it clear? See the definition. If number is k, so if k is positive number, if k is positive, and suppose f of n is equal to k, and therefore n must be positive, so n by 2 is equal to k. So what is n is equal to 2k? Right, that is why I have written here. If k is negative, and suppose f of n is equal to k, that means minus of n minus 1 by 2 is equal to k, and therefore what is n? What is n? N is minus 2k plus 1. Correct? Okay, so our time is over. Is it clear? Is this clear or not?
Yes, sir.
Right, so you just think about it. how to go back. If case, we should make cases, because when I select integer, then it may be positive negative, because our function is defined in splitted into two parts, for positive and for negative. Therefore, we should make cases. If k is positive, what should be pre-image, and if k is negative, what should be pre-image, and if k is equal to 0, we know that it is 1. So in this way you can write in detail, right? Okay, so we'll stop here. If you have any doubt, you can ask. Next time we'll discuss more about bijective functions.